Default subnet mask. A subnet mask is a number that accompanies an IP address and indicates which portion of the IP address is the network ID and which portion is the host ID. The IP address and subnet mask are interrelated, and each only has meaning in the context of the other. Without a subnet mask, there is no way to really identify which portion of an IP address is the network ID and which portion is a host ID. Now, the IP address and the subnet mask are the minimum address requirements required for any TCP/IP host or device. In many cases, we'll add a default gateway, that is the address of the router, but the minimum addressing requirements are an IP address and subnet mask. As I mentioned before, the subnet mask is a number that accompanies an IP address and indicates which portion of the IP address is a network ID and which portion is a host ID. Now, the best way to understand subnet mask is to view them from a binary perspective. Now, the ones in the subnet mask indicate which portion of the IP address is a network ID, and the zeros in the subnet mask then indicate which portion of the accompanying IP address is the host ID. Now, in our example here, the IP address of 207.23.106.99. Now, we know that's a Class C address, and that the first 3 octets are the network ID, and the last octet is the host ID. Now, when we look at the subnet mask in binary, we see that the first octet is set to 1s, indicating that the first octet of the IP address is the network address. The second octet of the subnet mask is set to 1s, indicating that the second octet of the IP address is also the network ID. The third octet is set to 1s, indicating the third octet of the IP address is the network ID. And then finally, the last octet is set to 0s to indicate that the last octet of the accompanying IP address is the host ID. Now, when we convert the subnet mask in binary to decimal, we see that it comes out to 255.255.2550. As we covered before, the classful naming scheme specifies that for a Class A address, the first octet is the network ID, and the last 3 octets are the host ID. Our subnet mask then would be set where the first octet is all 1s, indicating that the accompanying IP address, that the first octet is a network address, and the last 3 octets of the subnet mask are set to 0s, again indicating that the last 3 octets of the IP address, the Class A IP address, is the host ID. And when converted to decimal, this becomes 255.000. Class B, again, per specification, it says the first 2 octets are the network ID, so our subnet mask is set to 1s in the first 2 octets, and the last 2 octets of the Class B subnet mask are set to 0s, again indicating that that's the host ID. Now, Class C, first 3 octets are set to 1s because in a Class C address, the first 3 octets are the network address, and the last octet is set to 0s, indicating in a Class C that the last octet is the host address. And again, converting this to a decimal number, the Class C subnet mask becomes 255.255.255.0. So, in conclusion, the Class A default subnet mask is 255.0.0.0. Class B default subnet mask is 255.255.0.0. And Class C is 255.255.255.0. Now, these default subnet masks are the basis that we'll use for creating custom subnet masks in the next section. And remember, the subnet mask and the IP address are connected. They are interrelated. And the IP address has really no meaning without the subnet mask, because the subnet mask is the number that accompanies the IP address that indicates which portion of the IP address is the network ID and which portion is the host ID.